Welcome back to our series on probability theory. I'm Mark Ledbetter. This is lecture video 36, part B, and this is correlation. The third video on correlation should be the final one. So we've talked about covariance, we've talked about the properties of correlation, and one of those properties is that the correlation between x and y is the same as the correlation between y and x. Correlation of a negative x with y is the negative correlation between x and y. The absolute value of the correlation between a linear combination of x and a linear combination of y is simply the correlation between x and y. So scale, changing the scale of x or the units, translating or locating it differently, so adding or subtracting a constant, those do not change the correlation between the random variables, and that's good. The correlation coefficient has to be between -1 and +1. It can be -1, it can be +1. If the correlation coefficient, the absolute value of it is 1, then there are numbers b not equal to 0 and a such that y is equal to a plus bx. So a linear relationship between x and y has to exist. And that's called least squares or regression. We didn't really do the least squares method here, as far as I remember. But y hat is equal to a plus bx, as I mentioned. And then we came up with equations for our slope and for our intercept that you'll definitely want to know and probably use on homework. Okay, so we're going to do some examples this time. And so we finish this up, and so let's do this example. Let x and y have a joint PMF. So this is a discrete random variable, f of xy, and x plus 2y over 18. X can be 1 and 2, y can be 1 and 2. So our first thing that we're going to do is find the marginals. So f of x is going to be the sum across y, and that leaves us with this formula, 2x plus 6 over 18 for x equals 1 and 2. Don't forget your support for x because you don't have a PMF without that. And the marginal for y is the sum across x, and that leaves us with 3 plus 4y over 18, where y is, again, 1 or 2. And we want to know if x and y are independent, and the answer is no, because we take the marginal of f times the marginal of y, and let's see, this would be 6, this is squared, I forgot that on the bottom, sorry, and we get this, and this is not equal to x plus 2y. In fact, here is what it's equal to over 18 squared, not 18, and that's certainly not equal to x plus 2y over 18. So x and y are dependent. Now we want to find the mean of x and the mean of y. So to do this, we have to sum over both x and y of x times f of x, all right? And when we work through that, we end up with 28 over 18. You could also reduce that to 14 over 9 if you like. I don't think you want to do that with because of the mean of y and the calculations we're going to do later. To find the mean of y, we can sum y times f of xy over both x and y. We could have also used the marginal y f of y over x. We could also use that to find the mean of y, but I went ahead and used the joint distribution here. And so when we do that, so we summed over y first, and then we summed over x, and we end up with 29 over 18 as our answer for that mean. We also now want to find sigma x squared, sigma y squared, the covariance, and the correlation coefficient. So we've got e of x, so we need ex squared, and so we sum x squared times, this would be f of x, and so we multiply x squared f of x, and we end up getting 24 over 9 or 48/18. And so once we have EX squared and we have EX, which is mu, we can find the variance. So we plug in for the variance, and in this case we did want to reduce this mean to 14 over 9 because we ended up with 24/9 here for EX squared. We could have used 18, but when you're talking about the variance, it's usually better to use smaller numbers. So in that case, I often will reduce the fractions so that I don't have such large numbers to work with. And here we end up with 20 over 81. Same for e of y squared. I could have used the marginal, but instead I used, or I did use the marginal, yes. I used the marginal sum of y squared times f of y, and we ended up with 51 over 18. And so the variance here, in this case, we had 29 over 18 for the mean. We plug into our formula for the variance, and that is supposed to be a y, and we end up with 77 over 324 for our variance. That's the variance of y. To get the covariance between x and y, we need to have, the formula for that is e of x times y minus e of x times e of y. So we need the expectation of e of x times y. So there really is only one formula for that. That's the double sum, so the sum over x, the sum over y of x times y times f of x y. And I should have written that out explicitly. Well, yeah. And so in this case, I went ahead and did coordinates. So 1, 1, 1, 2, 2, 1, and 2, 2. Those are our 4 combinations there. And you could do a sum on y and then a sum on x, but for something so simple with only this many values, I use the coordinate type of method where I take all the possible combinations of x and y and plug them in. And so we ended up with 45 over 18 for e of x times y. We plug that in to our formula for the covariance, and we end up with a covariance of negative 1 over 162. Now we find the correlation, which is the covariance divided by the standard deviations of x and y. And don't forget to take the square root of the variance here. And so we plug in these values. We get negative, rearrange the fractions, and this is the absolute, or the exact value, sorry. We round rho and the correlation coefficient, whether it's rho or whether it's r, the sample correlation coefficient, to 3 decimal places. That is the convention. So negative 0.025. So negative, so there's a negative association between x and y. So as x increases, y will decrease on average, but it's very close to 0. So negative 0.025. Now we want to find the least squares regression line. So to do that, the first thing we need to compute is b, because we can't compute a until we have b computed. So we have to do b first. And so, again, I could have written this as b equals rho sigma y over sigma x if I wanted to do that. But that seems to be actually more complex, especially since rho is not a nice value. So instead I used this form of the equation. I plugged in. Don't forget that we already had x squared, sigma x squared, the variance. So we end up with a negative 0.025, but this is exact. So b is not usually equal to rho, and it's not in this case because this is not exactly 0.025. It's just rounded to 3 decimal places. This is exactly 0.025. And a is mu y minus b mu x, and so we plug in our values here, and we end up with this quantity here, which can be reduced to 33 over 20. So I don't need the hat. We use that when we're estimating. We're not estimating. This is the actual equation of y for the population. So y is equal to 33/20 minus x over 40. So that is how we do an example or a problem in this section. Okay, so Don't forget to scan and upload your lecture notes before midnight, the date listed in the course calendar. You'll definitely want to update your formula sheets with anything here that you haven't already updated it with. If you have a question, please come to virtual office hours. If you can't do that, then by all means email me. But when you email me, you need to send me two things. One, a picture of the problem so that I know what problem you're working and asking about. And two, a picture of your work so I know how you're approaching this and I can best help you. So I hope you will stay safe, take care of yourself, and we hope to see you next time.